All right, hello and welcome. Um, this is a stream about Proteus development. If you've been following along, this is like day 3 that we're on. Day 3 or 4? 3. Yeah, so Proteus is the language that I'm working on. It's kind of striking a balance between low-level functionality and a little bit more high-level semantics. So let's go ahead and continue where we left off. Okay, let's see, let's get our main file up, all right, and let's look at our parser. Okay, so last time, let's go ahead and build, make sure we're all good. We come over here and bin Proteus tests basic. We got the parsing working for our basic input statement. Let's go ahead and actually open up the file. Oops. Okay, so this is our basic Proteus file that we're going through and parsing. So we have the import statement happening, tokenized into some proper tokens, and then this is our little mini AST right here. Yes, so what we want to do is we want to go look at our parser and see where we kind of left that off at. Okay, so the way that we're doing this is we're basically writing these different handlers for different scenarios, and then if we get into one of those, we go ahead and start to parse. So if we have an import statement, then we go do it, we parse it, and then what we want to do, yeah, that's probably fine. So let's just go ahead and do the next one, right? Identifier. Right, identifier statement really, it's not really an identifier statement. It's going to be function call. I think we're just going to hard code for that. Let's just try that for now. Function invocation statement. Right. Then equals try parse function invocation statement. Pass in the lexer. Right, and if it worked, parse.pen function invocation statement. Okay. Alright, so we're down here. Gonna get a statement. Alright, so we don't actually have a statement for this yet. So let's come up here. And so currently our function supports parameters and string literals. Interesting. Okay, so here's function statement. Actually, let's get rid of the statement because we're already in an enum statement, right? So, right. So, is that all we need? Okay. All right, so, yep, okay. We have that. So there's some interesting things that we're going to deal with here. The first thing a function really needs is it needs first going to have an identifier, then it's going to have a parenthesis. So what I'm thinking here is what I'm a little bit worried about is that our lexer is going to have to look at 2 tokens to determine if we actually have a function, which means if it fails, I can't do the stall technique because I've used 2 tokens. Well, let's just write some pseudocode out here to see what the parsing mesh is going to look like. So I think what we want to do is we're just going to go ahead and follow a similar pattern from above, right? So guard let identifier token equal lexer dot peak. All right. So if there's nothing actually to look at, we're going to go ahead and return no. All right. So then we're going to do a guard case let identifier. I think it's an identifier. Yeah, these are our tokens. So let identifier. Actually, do we care what the identifier is? No, not this time. So I think we can actually just do this. Identifier token. Okay. So if we have an identifier token, then we're good. If it's not an identifier token, that doesn't mean we have an error. That just means that the parse function is going to ignore this. Okay. So, great. All right, now that we're in this state, so this is what I'm talking about, is that if we don't hit a parenthesis here, that doesn't necessarily mean that we have an error. That means that the function is not going to be used. So let's just open paren token. All right. So if our open paren token next gives us back nothing, it's no good. If guard case dot open paren token okay, even in this case, this is okay, right? Now I'm not sure we're ever going to have an identifier that's actually going to be legal like that. So we might not have to do the look ahead. Yeah. So this is what I'm thinking, is that we have our print that's going to have an identifier, but most of our other calls, and I'll have x equals, that's an assignment, which will have an identifier. Okay. Yeah, we're going to have to figure out how to do, we're going to need to add that to our lexer. Okay, so now that we have a parenthesis, we're saying, okay, this is a function now. You have started to create something that looks like a function, so now you need to make it act like a function. So any time we get an error here now, we're going to go ahead and throw. So let's actually So I haven't done the tokens for string literals, have I? No, I did. Okay. So our parameters, I haven't done numbers. Done string literals. I haven't done numerical literals. Okay. Well, let's just do what we have today. So what we have today are strings. So let's see here. Params, they can be a string or nothing. Okay. Okay. All right, so what we want to do is let's go ahead and get the next token. I don't know what it is anymore, so we're going to name it just next token equals lexer.next. Right, so this has to be, we're going to do while let next token equals that where let's just do that for now. All right, so while the next token is not nil, right? Okay, now if we get down here, let's actually go ahead and throw the error. All right, so and now let the function location. This is not a declaration. Okay. All right, so while the next token, while it doesn't equal nil, what we need to do is say if the token is a close paren, we're good, right? We're done. We've hit a function. Happy days. And then we want a terminal, right? All right, so if case dot close paren equals next token. All right, so if it is indeed the case that the next token is a closed paren, then we need to also make sure that the next token is a, okay, case terminal equals lexer.next. If that's the case, we have a valid function. So let's go ahead and return our function statement. And our function statement today looks like nothing. So we're going to give it a name, which is the token. Parameters, which is an array of tokens. Okay. Yeah, I was thinking of adding that parens and stuff, but we don't need those. Yeah, I don't think we need those in our actual statement AST. All right, so we have a function statement. Then what we're going to do is we want that value out. All right, so, okay. So the name is going to be the identifier token. And the params, now, it's going to be an empty array. All right, so what we need right here is a list of parameters. It's going to be a token array, an empty one. And so, whoops. Params, there we go. Okay, so if we have a closed paren, okay, if we didn't get the terminal, then we're going to throw right, we're going to come through and actually fix all these error messages as we actually go and fix this code so that it works in more generic cases. Okay, so in the case of not getting a closed param, then oh, you know what's interesting? I'm going to need to inject a terminal before an end of line or end of file marker. Okay, I'll do that. So if case close parent next token. All right, so otherwise, if case dot string literal equals next token. All right, string literal. Okay. All right, so then if the string literal all right, well, if it's a string literal, we're going to go ahead and do this. Param period append next token. Okay. Then, so I'm thinking of how am I going to handle multiple parameters, but all right, we don't have multiple parameters yet, so let's just go and see if this works. All right, so we're going to string literal. We're going to append the token. We're going to come through here again. We should get a closed paren. Okay. All right. And if case.terminal, if we ever get a terminal here, we're going to just bail early instead of going to the end of all the tokens, because that's going to be... Actually, let's just do if we don't get one of the supported ones. Yeah, let's just do that. Alright, so I could actually probably turn this into just a switch statement. Alright, so let's switch on the next token. I think this will clean this up a little bit. Oops. Delete to end of line. Okay, whatever. All right, case string literal. And then default case is throw there dot invalids index. All right, and then close out the switch. Okay. Function statement. Oh. Oops. All right. So well, I guess we're okay because then the file is going to return nil. Okay. Well, yeah, because I got the close param. I think I want to put some debug stuff in here so that I can actually output what my tokens are when I call next. I'll do that a little bit. All right, so anyways, this is our correct parse tree. Like, I mean, that's valid. It is the correct thing. It's a terrible implementation of a parser, but like we have basically created the very basics of this abstract syntax tree, this AST here. Now, there should be like a top level that these things get rooted in and all that jazz, but that's okay. For now, this is sufficient. So what I actually want to go ahead and try to do now is come on over here. Oops. Here. All right, so we come in here, we've gone through and we have parsed the tokens. Yep, okay, I like it. We go through, we list them out, all good. So now, what we're gonna do is we're gonna go ahead and start on our really basic C rewriter. And so what this is gonna do is it's gonna take tokens and it's gonna convert them into the quote-unquote machine code, which is gonna be C code in this case. And we're gonna cheat a whole bunch on this. All right, so let's just go ahead and get started and make this thing work. So really all we're doing is we're writing this program, or writing this parsers to basically, it's almost special casing our input file, but we'll start to expand on that. So we're gonna go ahead and create a new class. I'm gonna call this, I mean, it's not a compiler, but sure. I don't want to call it that. I'm just going to call it a rewriter. It's going to rewrite one AST and turn it into another piece of code that's going to happen to be C. Okay, so we have our rewriter. Inside our rewriter, we are going to need, let's see, we're going to need a list of tokens. Yeah, I think our rewriter is just going to actually ask for tokens and go do something with it. Yeah, I like that better. Right now we kind of have this nested structure of the parser contains the lexer, and the lexer contains the scanner, and the scanner contains a file. It's kind of ugly. I think I'd almost rather break that out and say create our scanner, pass the scanner into the lexer, create our lexer, pass the lexer into the parser. Yeah, I should do that because what I've done is I've coupled this parser to this particular lexer. Yeah, all right. One of the many things to do to start cleaning this stuff up. Okay, so let tokens. Let's just go through this token. But I mean, that's just one of the ways I code. Is I just like to get stuff actually working. That way I know what I'm supposed to be, the problem. I get a better understanding of what the problem is, and then I can start reshaping my code to make it look like something that's actually good and will work and will actually scale a little bit better to other scenarios. But it's just an iterative process for me. Okay, so I think we're just going to have a rewrite, and we're just going to give you a string. I think rewrite. How about convert to C? Maybe we'll just do I mean, we don't even need a class for this, right? I don't know. We probably don't even need a class for this. This is just a rewrite function. It's just convert tokens to string. It's just a function. Yeah. All right. So then we're going to come over here. Let's see code. Actually, let's just say code. Let code equal convert tokens to C, and we'll pass in our tokens. Right. So our C code is going to look like this. Okay. And then we're just going to go ahead and write out the code. What? Oh! Okay. Right. These are not tokens. This is our pseudo AST. Okay. So convert AST to C. Write parsed token. Those aren't actually tokens, those are statements, right? The parser parses something and gives you back an AST. Okay. That's why I was getting a little bit messed up here. So for each statement, I don't even, what's the point of that? Excellent. All right, so we're gonna have our code just to get output right there. Okay. All right, so return code. Okay, so what we're going to do is just loop through all the statements. Okay. And we're just going to switch on them. Right? Yeah. Then we're going to do case. Our first thing we're going to do is import. Yep. Let import identifier. What's the other part of it? Value. Alright, so dedent. Yes, there we go. Alright, so if it's an import, okay, then we're going to check. If identifier equals standard lib, we'll say, hey, we handle this. Otherwise, we're going to throw. We're going to throw an error? Yeah. I don't know what kind of error. It's probably not going to be air. Yeah, we're gonna want a new air type for this. But let's tag it on here for now. Generic message. We're just going to use that going forward as just our generic placeholder for something that throws. Swift doesn't have typed exceptions anyway, or type errors anyways. So what's the point? Throw error not generic. This import is not yet implemented. Okay, if it does happen to be a standard lib code, we're going to append to the code a pound include standard lib .h with the new line. Okay, yep, that's good. Alright, so case let function. Alright, we have the identifier. And we have the params. Yeah. Okay. Yep. So let's come over here. Why did my buffers get switched? I don't know. There we go. Okay. What was I going to do? Okay. Oh no, I had a compiler. Identifier. Identifiers. Oh yeah. Identifier is the token that got in there. So what we actually need to do is we need to pull out the value of the token. I think what I want to do so I can either write the switch statements all over the place, or I think what I'm going to do is write a function here. I don't know if I like this yet, but and it's going to go ahead and give me the string value of a particular type. Oops. What's going on? There we go. That's what I wanted. Case let identifier value. Okay. Case let dot string literal. Yeah. Case let dot keyword. Okay, what else? Default Okay. Oops. Where are we going here? All right. Okay. I guess I could make that a property instead. All right, let's do that. What? Enum case identifier is not valid. You are right. All right, so immediate value was never used on import. Value line 265. All right, case let value. Oh. Well, my string value property has already been removed. All right, let's rethink that just real quick here, because no. I'm just thinking about this wrong. This is a statement. This import is the identifier. The identifier dot string value. I just looked at the wrong one. That should actually be value. But this is correct. I do not need that. Okay. All right. Now, what we need to do is we need to convert certain functions that we write into their C corresponding items. So, if identifier dot string value was the print function, we're actually going to convert that to printf, right? Then we're going to go through, no idea why that's indented that way. Then we're going to go through all the parameters. Yeah. We're going to join them. Yeah, okay. All right. If identifier string value equals print, code plus equals print, the params. Params is an array. I'm going to map it to a different array. Okay. I'm going to go through, get all the string values of them. Okay, that's going to turn it into an array of strings. Okay. And then I'm going to do components separated by string. Separated by string. And that will do the NS array has no, is that, what is that on? let's look at the docs. It's really annoying that like the watch OS and TV OS docs show up first now. I mean, they should be the same, but I just want NS string or NS array. Really? Oh my goodness, enters. Okay. Components joined by string. That's right. That makes more sense. Delete backwards. Oh. Components joined by string. There we go. All right, let's see what we got so far. We go do that. We got some code. We got optionals for some reason. But as you can see, we almost have valid C code here. What's up with this optional crap? Does components joined by string return an optional in Swift? Components joined by a string. Interesting. All right, well, I mean, if I comment out this line, is this the one that's doing the optionals? What is going on here? I'm like atrophying all my Vim knowledge. Nope, it's not that. Okay, so code value string value. String value won't be optional either. Oh, right. So, yeah. Oops. All right, we did the try. We did the try, and then that converts the result to an optional because we did try question mark. This guy right here takes that string result that we were getting and then types it out, and we get that lovely garbage. Okay, so yeah, we're almost there. Let's put this back in. And then we're going to need to get that semicolon. Boom. So that would be valid Swift, or valid, actually that would almost be close to valid Swift code. But of course that's actually not going to turn into a program. And so this is where things like the maybe that top level, or basically we need to surround this code in the int main stuff. And I'm trying to think of the least hackiest way to do that right in here. Right, because this code is not going to compile if we were to try to compile that. Yeah. So, I mean, one way to do this is to, yeah, the way in which our AST setup right now is not going to be the greatest thing for here. Right, because if we look at this, we're going to have our imports, right? And this thing right here is actually in some implied body that I'm not actually injecting into the AST yet. Because right, if we look at our tests basic prot, what I'm giving you is an implied main function right here. And so, maybe let's go add that. Let's see here. Just trying to figure out if we have enough time for that. Alright, that's going to be more than I want to do right now. So let's just go ahead and hack this up, and we will definitely fix this later. Okay, so we're going to do int main okay. Like I said, this is super hacky. Okay. But we're going to go ahead and just rebuild. Alright, so we got include standard lib, we got int main, then we got printf, then we got return 0. Okay, in theory, this should totally work. Alright, so now what we want to do is we just want to simply output this file. So where do we want to do that at? Alright, so we got our conversion. Let's just go ahead and do it this way. So we have code as in a string. I think we just have a right to file. Oh my goodness. multiple documentations. Awesome. Oh, good. Can I get rid of this crap? I only want OS 10. Thank you. And what? This is awesome. Okay. Writing to a file. I think it's just write to file. Yeah. Okay. Write to file. We're just gonna name this. I mean, I guess we could get the file name, but this is gonna go away anyway. So basic.c atomically is true. Right? What's the problem with this? Oh, encoding. All right. Oh. Oh my goodness. So this can grow. All right. So we have no C file here. We call that. We have our basic C. Yay. Okay, if we can just call clang on basic C, it should work. First parameter of main. Oh, did I flip those? Oh yeah, I meant to do IO. Yeah, we're actually probably gonna like end up importing a bunch of headers for now, anyways. But let's just do this. Okay, clang, basic C, excellent. A out. Welcome to Proteus development. So there we go. We have essentially compiled. We still have a few little manual steps along the way. But we have now gone from this guy into converting it into tokens, and then converting this into a very primitive AST, and then taking that AST and then turning it into C code that we can then go turn around and compile. So I think that's good for tonight. Next up is actually fleshing out this, actually making this Lexer do the right stuff. It needs to inject the body here so that we don't need to do this hacky stuff to put in there. We need to actually start supporting real parameters. We need to start supporting assignments. So these are just kind of all things that just need to start getting iteratively added into our Lexer. So yeah, all right. Until next time.